we're going to work on finding what we call absolute maximums and minimums of functions. And to understand this, we should understand what an absolute max and min is, what they are. So when I have a curve, and I draw this curve, it's going to draw lots of maxes and mins in here. Okay, well, if I pick a specific interval, let's say I'm just going to pick a random one here. Go like right here. I'm going to go all the way until right there. Okay, this is an interval of values that we're going to focus on within this graph. All right, so we have these different maxes and mins within the function, these bumps right there, right there, right there, right there, within this interval. And we call those local maxes and mins. Because locally, in their area, they are the biggest value or the smallest value. Every other value around it is either bigger or smaller. If I zoom in on this, to the left and to the right, all those points are smaller. If I zoom in on this, to the left and to the right, those points are bigger. It's just a max or a min, all right? But within this interval, this is not the smallest possible value. If I look at my interval, over here actually is the smallest value. This is the lowest negative number, right? This one is not the smallest. It is a local minimum, but it is not the absolute or global minimum. So I call this guy over here the global or absolute minimum because it is the smallest value on my interval. Now, if I look at this guy, he is a local maximum because he is the biggest point in his area, right? But he's not the global max or the absolute max. The global or absolute max is up here. This is the global or absolute max. Okay, so it is just the largest value in our interval. And then the global or absolute min is the smallest value in our interval. All these other maxes and mins we just call local maxes and mins. So now, looking at a function, our goal is to try to determine the absolute or the global maxes or mins. So our first step here is to find critical points, and you should know when given a function how to find critical points by now. If I have a function, I want to find its critical points, I'm going to take the derivative y prime, which equals 2x minus 6, and then critical points are going to happen when this derivative is set equal to 0. So that's not too hard. 2x minus 6, we have a critical point at x equals 3. So now what we have to do is we have to plug in that critical point back into the function up here, okay? And then we also have to plug in these endpoint x values into the function as well, because think about our picture from earlier, all right? So I erased some of it, but we had to check all these critical points here, all these maxes and mins, but we also found that at this endpoint, there was a smallest value. So we have to check the x values at the endpoints, but we also have to check all the x values at the critical points to see if we have, or where we have the biggest and smallest y values. So we're going to plug in our critical point and our two endpoints. So first we'll plug in the critical point, or I guess, down here, I forgot, I have another thing on this page. Okay, so I plugged in the endpoint x equals 5 first, and I'm just plugging this into the function to see what the y value is. So I get 5 squared minus 6 times 5 plus 3, which equals negative 2. Okay, so I know that at 5, the y value is negative 2. I don't know, that could be the max or the min at this point. I need to check the other points. I need to check x equals 2, and I need to check the critical point. So when I check x equals 2, I get negative 5. So far, this is the smallest value we've gotten. This is the biggest, but now we have to check the critical point as well. So we check the critical point at x equals 3. We get 3 squared minus 6 times 3 plus 3, which is negative 6. So that is our smallest y value. We'll call that the absolute minimum. And then we see that negative 2 is the biggest y value, so that's going to be the absolute maximum. So we can look at a picture. Here's my interval. So we can see that we have down here, this is our our absolute minimum, all right? And then over here we have our absolute maximum. Because the only 3 points we have to consider are this one, and this one. We can see this is our smallest possible y value. And then as we move along our interval, this is our biggest possible y value. So that is our, at 5, we have a y value of negative 2. And then at 3, we have a y value of negative 6. Absolute min, absolute max. Okay, so let's try another one. We're going to find the absolute minimum and the absolute maximum of y equals x cubed minus 12x squared plus 21x. See if you can remember the steps. Give it a shot. So pause the video and give it a shot. Do you actually pause when I say this? I'm going to guess like 60% of you do not pause when I say this, but that's okay. If you did pause and now you've unpaused, now you're just annoyed that I'm still talking about the whole pausing situation. But anyway, let's move on. So we need to find our critical points first. So I found my derivative, which is 3x squared minus 24x plus 21. And then I factored my derivative, and I found that my critical points happen at 1 and 7. So those are the points we are going to consider, and then we're also going to consider our endpoints at -1 and 2, because that's the interval we were given. So when we plug in -1, okay, we're going to get -1 cubed back into the original function here. -1 cubed minus 12 times -1 squared plus 21 times -1 should give you -34. Next we plug in 2, the other endpoint. So we get 2 cubed minus 12 times 2 squared plus 21 times 2, and that gives us +2. Okay, so now let's plug in our critical point at x equals 1. So we plug in x equals 1, and we get 1 cubed minus 12 times 1 squared plus 21 times 1, and that should give us 10. And then we actually don't have to plug in x equals 7, because the thing is, this interval, and the spacing got all messed up here, but the interval is from -1 to 2, right? From -1 to 2, and 7 like falls all the way out here. So 7's not even in the interval, so we don't have to consider 7 in this case. So now we just have to look at these three values, and we see -34 is the smallest, and then 10 is the biggest. So our absolute max is at 1, 10, and our absolute min is at -1, -34. Okay, so let's look at a graph. Here it is. Okay, so there is our absolute max that we just found, and here is our absolute min that we just found, because remember, we're only in this interval from -1 to 2. Clearly, out here we have the point at 7, -98, which is the smallest value in this area, but it's not in our interval. In order for this to be included, our interval would have to be like over here, right? The other endpoint. But since it's not in our interval, we don't even have to consider it. We just have to consider this critical point, this endpoint, and then this other endpoint. We're going to finish with a slightly harder one. See if you can get this derivative. Okay, remember how to find this derivative. There's a couple tricks or a couple rules involved here. So we have y prime equals. This is a product rule, so we have to do the derivative of x first, which is just 1, times e to the -x, and then product rule says plus x times the derivative of e to the -x, but e to the x is its own derivative, and then we leave the inside alone, but then we now have to multiply by the derivative of -x, which is just -1, and all that's going to do is just make this, instead of positive, we're going to multiply by a negative, which makes this minus. Seems like it's going to be hard to find critical points here, but it's actually not so bad, because I have a common factor. I have an e to the -x, and I have an e to the -x that I can factor out. So I get e to the -x, what's left over? I have a 1 minus x is my y prime. Okay, e to the -x is never going to be 0, because no matter what I plug in, I'm not going to get 0. If you plug in 0, you get e to the 0, which is 1. If you plug in positives or negatives, nothing's going to make this 0, so forget about it. But this does tell us that we have a critical point at x equals 1. Okay, so critical point at x equals 1, so we have to check that. We also have to check our endpoints at 0 and 2. Okay, so yeah, here we go, critical point at x equals 1. And here's the graph just for context. Like this, clearly we can see here where the absolute max and mins are, but we're going to actually find it, because in this type of question, you're not just going to be given the graph. You're only going to be working with the function, and you won't have a graphing capability. So if we plug in our endpoints at x equals 0, and remember, we're plugging back into the original function here, we just get 0 times e to the 0, which is just 0. Okay. Now if we plug in 1, we're going to get, or let's plug in 2, because that's our other endpoint. Y of 2 equals 2 times e to the -2, which is 2 over e squared. And then if we plug in our critical point at 1, we get 1 times e to the -1, which is 1 over e. So now the question is, I mean, clearly we have two positive numbers here, so clearly this is the absolute max at 0, because, or no, sorry, the absolute min is what I meant to say, because that's the smallest number, because these two are both positive. How can we figure out which one of these is bigger? One of these is the max, right? Well, we don't have a calculator, so we're just going to have to do our best. And what I'm going to do is round e to 3, right? It's like 2.71. So let's round e to 3 and see what we get. 3 squared is 9, right? Okay, so we have 1 over 3, which is like 3 over 9, versus 2 over 9. Of those, 3 over 9 is bigger, just slightly. So that's going to tell us that 1 over e is slightly bigger than 2 over e squared, and that's going to be our max, okay, our absolute max. So we have 1 comma 1 over e, and then we have 0 comma 0. And then we can see that in this graph, because here we have 0 comma 0 is the minimum in this interval, and then this just barely, at x equals 1, we have our maximum. On our other interval, this is slightly below this one, which is what we found down here when we compared the two by doing a little bit of rounding. That's all. Why is there another slide? Oh, it's just showing that work again. Okay, cool. That's it. Hope you took notes and submit those on Classroom.